Voyager 1, the most distant human-made object in the universe, has once again started sending usable information to Earth. NASA engineers successfully re-established communication with the spacecraft, which had been transmitting a stream of unintelligible code. This recent breakthrough has sparked intrigue and excitement among scientists and space enthusiasts alike. A significant revelation came when renowned science communicator Bill Nye claimed that Voyager 1 had detected 300 massive objects in space. This unexpected discovery has fueled speculation and raised profound questions about what these objects are and where they might have come from. For nearly half a century, the Voyager missions have provided humanity with some of the earliest and most remarkable views of our solar system. Initially, these spacecraft were not designed to last as long as they have. In the 1970s, Michael Minovich conceived a groundbreaking idea that would allow a spacecraft to use a planet's gravitational velocity to propel itself farther into space. This concept, known as a gravicyst or slingshot maneuver, allowed Voyager 1 and Voyager 2 launched just weeks apart in the summer of 1977 to explore the outer planets. Originally planned to last only 5 years, the mission far exceeded expectations. The spacecraft were first tasked with studying Jupiter and Saturn, which they accomplished with great success. But instead of concluding their mission there, Voyager 2 went on to make history by becoming the first spacecraft to conduct close-up observations of Uranus in 1986 and Neptune in 1989. This incredible sequence of planetary flybys was dubbed the Voyager Grand Tour. Rather than ending their journey, these resilient spacecraft set their sights on an even more ambitious goal: exploring deep space. Now, 46 years after their launch, both Voyager 1 and Voyager 2 continue their mission, gathering invaluable scientific data from the farthest reaches of the cosmos. In a groundbreaking announcement in 2013, NASA confirmed that Voyager 1 had officially entered interstellar space. This vast region, situated beyond the influence of the Sun's particles and magnetic fields, represents the transition from the solar system into the broader galaxy. Moving from the solar system into interstellar space is akin to leaving the confines of a bustling city and stepping into an endless star-filled wilderness. 5 years later, in 2018, Voyager 2 also crossed this boundary, reaching a distance of approximately 17.7 billion kilometers from the Sun. Voyager 1 and Voyager 2 remain the only spacecraft to have ventured into interstellar space. Their mission has allowed scientists to study how the interstellar medium interacts with the solar wind, charged particles continuously emitted by the Sun. These spacecraft serve as humanity's cosmic messengers, offering unique insights into the heliosphere, the protective bubble surrounding our solar system. The heliosphere is shaped by the solar wind and acts as a shield against cosmic radiation. Voyager 1 and Voyager 2 have provided invaluable data about the celestial barrier, helping scientists understand its structure and behavior. As these spacecraft traveled beyond the heliopause, the boundary where the influence of the solar wind ends and interstellar space begins, they made astonishing discoveries. One significant finding was that cosmic rays, high-energy particles originating from deep space, are 3 times more intense beyond the heliopause compared to within the heliosphere. This difference is similar to the contrast between the relative calmness of a backyard and the chaotic activity of a busy street. Scientists have also combined data from other space missions with Voyager observations to create a more comprehensive picture of the Sun's interactions with the interstellar medium. Adding to the growing list of intriguing discoveries, NASA scientists announced a remarkable finding last year. Voyager 1 had captured a low-frequency hum emanating from interstellar space. This sound was identified as the faint vibrations of plasma, or ionized gas, floating in the vast emptiness beyond the heliosphere. Nicola Fox, head of NASA's Heliophysics Division, emphasized the significance of the Voyager missions, stating that their contributions over the past 46 years have fundamentally changed our understanding of the Sun and its impact on the surrounding space environment. One of the most extraordinary aspects of the Voyager missions is the resilience of these aging spacecraft. Both Voyagers rely on radioisotope thermoelectric generators, RTGs, powered by plutonium. As the plutonium decays over time, it produces less heat, leading to a gradual decline in the spacecraft's power supply. To extend the missions as long as possible, NASA engineers have had to make difficult decisions. shutting down non-essential systems and even turning off some that were once considered necessary. One particularly surprising decision was to deactivate the heaters responsible for keeping certain instruments warm in the extreme cold of space. Despite this, all 5 scientific instruments on board have continued to function since 2019, defying expectations. Scientists are baffled by how the Voyagers are still operational in temperatures that would normally freeze other spacecraft. For decades, the dedicated efforts of the Voyager team have allowed humanity to explore the mysteries of space beyond the solar system. The information provided by these spacecraft has deepened our understanding of the cosmos, revealing unexpected and sometimes baffling phenomena. The Sun, despite appearing as a tranquil sphere of light, is actually a dynamic nuclear engine hurtling through the Milky Way at an astonishing speed of 450,000 miles per hour. It is surrounded by an intricate web of tangled magnetic fields that continuously interact with the interstellar medium. As the Sun moves through the galaxy, it emits a constant stream of charged particles known as the solar wind. The solar wind does not simply dissipate into space. Instead, it collides with the interstellar medium, which consists of the remnants of ancient star explosions. These two forces do not mix seamlessly. Rather, the solar wind carves out a vast bubble within the interstellar medium, forming the heliosphere. Thanks to the data collected by the Voyager spacecraft, scientists now know that the heliosphere extends approximately 11 billion miles from the Sun at its leading edge. This protective shield encloses the Sun, all 8 planets, and many other distant objects in the solar system. Beyond serving as a mere boundary, the heliosphere plays a crucial role in shielding Earth and other planets from the galaxy's most intense radiation. Without it, life on our planet would be subjected to far more hazardous cosmic rays. To further unravel these cosmic mysteries, scientists must continue studying the heliosphere. NASA plays a critical role in ensuring that the Voyager spacecraft remain operational despite their immense distance from Earth. Updating the software on these probes is no simple task. Given their outdated technology, engineers must communicate with them using a highly basic form of programming known as machine language. Unlike modern computers, which rely on operating systems and sophisticated programming tools, the Voyagers require direct, low-level instructions that the onboard hardware can interpret. To achieve this, NASA engineers use assembly language, which allows them to exercise precise control over the spacecraft's functions while optimizing performance. Additionally, they employ pseudocode, a simplified programming approach that automates repetitive tasks without consuming excessive memory. These software updates are about much more than fixing glitches. They are vital for the continued survival of these pioneering spacecraft. As Voyager 1 and Voyager 2 continue their historic journey into interstellar space, their endurance serves as a testament to human ingenuity and perseverance. The data they collect will undoubtedly shape our understanding of the universe for years to come. With each passing day, they travel farther into the unknown, carrying humanity's hopes and curiosity to the furthest reaches of the cosmos. Voyager 1 and Voyager 2 have become symbols of human perseverance and curiosity, carrying our quest for knowledge far beyond the confines of our solar system. Their journey has not only redefined our understanding of the Sun's influence, but has also hinted at mysteries that challenge our existing scientific models. One of the most intriguing recent developments has been the claim that Voyager 1 detected 300 massive objects in interstellar space. While details remain unclear, this revelation has sparked excitement and speculation within the scientific community. Could these objects be rogue planets, clusters of cosmic debris, or something entirely unknown? The answers may redefine our understanding of the structure and composition of interstellar space. The continued survival of the Voyager spacecraft is nothing short of miraculous. As their power supply diminishes, NASA engineers are constantly faced with difficult choices regarding which systems to keep running. The fact that they have managed to stretch the mission decades beyond its intended lifespan is a testament to both the durability of the spacecraft and the ingenuity of the scientists maintaining them. One of the greatest challenges is the sheer distance involved. With Voyager 1 now over 15 billion miles away from Earth, communication takes approximately 22.5 hours one way. That means any command sent to the spacecraft requires nearly 2 days for a round-trip response. Despite these challenges, NASA continues to troubleshoot issues and send updates, ensuring that these distant explorers remain operational for as long as possible. Beyond technical hurdles, the Voyager probes are also providing insight into the very fabric of space itself. Scientists initially believed that interstellar space would be a vast, empty void. But the data from Voyager 1 and Voyager 2 has shown otherwise. The discovery of a persistent low-frequency plasma hum in interstellar space suggests that this region is more dynamic than previously thought. Plasma waves, formed by charged particles moving through space, could provide critical information about the interactions between interstellar material and the Sun's extended influence. By studying these waves, scientists hope to better understand the environment through which our solar system moves. Another surprising revelation from Voyager 1's journey into interstellar space was the unexpected pressure exerted by interstellar material. When Voyager 1 crossed the heliopause, scientists predicted that it would enter a relatively uniform region of space. However, data indicated that the interstellar medium was denser and more turbulent than expected. This suggests that the region beyond our solar system is not as homogeneous as previously believed, but rather a dynamic and constantly shifting environment shaped by magnetic fields, stellar winds, and past supernova explosions. Understanding these forces is crucial, as they influence not only the heliosphere but also the future of our solar system as it moves through the galaxy. One of the most profound contributions of the Voyager missions has been their role in expanding our knowledge of the heliosphere. Before their launch, scientists had only theoretical models of this vast protective bubble surrounding the Sun and planets. Thanks to Voyager data, we now have a clearer picture of its structure, including its shape and the way it interacts with the interstellar medium. The heliosphere serves as Earth's first line of defense against high-energy cosmic radiation, deflecting many of the dangerous particles that could otherwise pose a threat to life.